All right, so let's see what we have. First, let's figure out what the given information tells us. So secant of x is equal to 4. And then we're asked about sine, cosine, and tangent. So my first step, I believe, would be to rewrite secant. Secant would be 1 over sine of x. So we can say that's our given information.
Isn't it cosine?
Secant is 1 over cosine. Yes, thank you for pointing that out. And then if I flip both sides, that tells me cosine of x is 1/4. And I want an angle between 270 degrees and 360 degrees, so that's going to put me in the 4th quadrant. And I'm going to actually relabel that 2. I don't like calling that x. I would rather call it theta. Make all of these thetas. So on the unit circle, x equals 1/4 here. And if I want to be in the 4th quadrant, then the angle I want is that one right there. So this right here is the angle theta that I'm playing with. Next, if I know the x value on the unit circle, then I can calculate what the y value should be. So Pythagorean theorem, x squared plus y squared equals 1. So I'm going to have 1/4 squared plus y squared equals 1 squared. That, so that's going to be 1/16. So y squared will be 1 minus 1/16, 15/16. So y is going to be plus or minus the square root of that. And 16 is nice. We'll take its square root, so plus or minus square root of 15 over 4. So now for this particular angle where the secant of, I'm going to call it theta again, is equal to 4, we know that the cosine is 1/4 and the sine is, in this case, the negative square root of 15 over 4. And now I can use our identities to rewrite, say, part A, sine of theta over 2. So if you have that memorized, great. If not, look it up for now. So I'm going to make believe I don't have it memorized and look back here. Have it there, and it should be up here too somewhere in a little box. All right, so sine of an angle cut in half is plus or minus 1 minus the cosine of theta over 2 inside the square root. And we have to decide whether we need a plus or minus here. So if we cut theta in half, let's try red. That's going to be somewhere, let's see, where is that going to put us? In quadrant 2 somewhere. So somewhere in here is going to be half of theta. And the sign in that region is going to be positive. So I'm going to get positive square root of 1 minus cosine of theta over 2. And I know the cosine of theta is 1/4 here. So then I'm going to get 1 minus 1/4 over 2 inside the square root. There's a little arithmetic to do. That's going to be 3/4 over 2, which which is 3/8. So that's one version of the answer. My math right, let's double check. 1 minus 1/4 is 3/4 times a half. Yep, that's good. Now, we could clean up the denominator a little bit and maybe rationalize it, but in my opinion, rationalizing denominator is a waste of time. So I would just stop there. That's a nice answer. Okay. Perfect squares, I think you should be obligated to put all perfect squares. But rationalizing square root 3/8, I think is unnecessary. So that should be the sine. Cosine theta over 2 is a similar formula. We have to decide whether we want the positive or the negative. What do we want in this case? Positive or negative root of theta over 2 cosine. And so look, again, theta is my big blue angle that put me here. If I cut that angle in half, I'm going to estimate that I'm about there. And the y value is positive there, but the x value is negative. So cosine of theta over 2 should have a negative value. So this should be negative square root of 1 plus the cosine of theta over 2. So cleaning that up, we're going to get a 1 plus a fourth over 2. So that would be 4/4 plus 1/4 is 5/4 divided by 2 should be 5/8. And it should be negative. And then the tangent, I mentioned the other day, there is a formula for tangent, but I think it's easier to just do it as sine over cosine, which we've just calculated. So for C, for the tangent, theta over 2, I'm going to say that is the sine, theta over 2 divided by the cosine, theta over 2. Let's see, sine ended up being square root of 3/8. Cosine square root of 5/8. Order. And this, we should take the time to clean up a little bit. Since everything's positive, I could just bring them together in one square root. And dividing is the same as multiplying by the reciprocal. So that's going to be 3/8 times 8/5. So then I'm going to get the square root of, and I missed something. One of these is negative. 3/5 inside the root. And again, rationalizing denominators, usually a waste of time, don't bother. Okay, double checking the idea of the tangent. The tangent is the slope of this radius here, and that radius has a negative slope, so that seems reasonable. I think these are my sine of half the angle, cosine of half the angle, and tangent of half the angle. And because of this quadrant configuration, we get a positive, negative, negative for them respectively.
This one was way easier than 25. Because 25 was the cosecant. So you had to use the Pythagorean theorem to find the